So, good afternoon, everyone, and welcome to this lecture. This is lecture number 7 in magnetic effects of current, and what we are dealing with is the force on a charged particle or a charge. In the previous class, we had seen that the formula for magnetic force on a charge is given by QVB sine theta. If I talk about in terms of the scalar formula, to find out the direction of force, we use cross product V cross B, and that is how you get the direction of magnetic field or magnetic force. We also have the vector formula Q V cross B, and we had seen a couple of questions where we had put that formula by taking the cross product. We were also looking at how can we find out the formula, how can we find out the magnetic force by the direction. So let me just continue on this. If I have a minus q charge like this and it is moving with a velocity v like this, the magnetic field is inside the sheet going into the plane of the paper. What will be the magnetic force on this charged particle? What will be the magnitude and what would be the direction? Yes, who is going to tell me the magnitude and direction of this magnetic force on this charge? Obviously you can convert them into vectors and get your answer, but getting the answer in the scalar form is always more beneficial. And so I'm asking you, what will be the formula for the force? Yes, who will tell me what will be the magnitude and what will be the direction? No one knows it. No one knows it. No one remembers it. So I'll give you 5 minutes. Go through what we had done in the previous class. See the formula and let me know once you understand it. V cross B, that is what you need to do. Go through what we had done in the previous class. I'll give you 2 minutes. Go back and have a look and let me know once you are ready. That is correct. The value of force, F, magnitude, Q is charge, V is velocity, B is the magnetic field. The angle between V and B, V is along y-axis, B is going inside, so angle is 90. Sin 90 is 1, QVB. Now you have to find out the direction. You just have to rotate your hands. V is in the upward direction, B is inside, so the force will be like this. If it was a positive charge, it would be like this, but this charge happens to be negative, and therefore the force will be in this direction. As you can see, all the three quantities F, V and F, they are mutually perpendicular to each other. Do we understand this? Yes or no? Yes or no?
Sir,
Anyone understands this? Comes the next one, and again you have to give me the answer. uh, Positive charge plus q is moving with a velocity v like this. The angle here is 30 degrees and the magnetic field is going inside. Again, we'll give you 2 minutes to tell me the answer. In this case, V is at an angle of 30 degrees, B is inside. What is the magnitude and what is the direction of magnetic force? I'll give you 2 minutes. Give me the answer. If you can understand this, everything else is very simple. So I'll have to do it. The force F, you just have to put one formula, nothing else. Q, V, B. What is the angle between V and B? Here. What is the angle between V and B here? Yes. No one, can anyone tell me that? No one knows the angle between V and B? Yes or no? It has to be an answer. Either it's yes or no. No answer is no answer. I mean, I don't understand. Do we understand the angle between V and B?
No, sir.
In which direction is B going? Do we understand this? In which direction is B going? Do we understand this?
Yes, sir.
Which direction?
Inside.
Inside. Where is your V? Inside means which axis?
Z. Like K. Minus K.
Which? Minus K. In which plane or in which axis or in which plane is the velocity V?
X, Y.
XY. And magnetic field is in the minus Z axis. What is the angle between XY plane and minus Z axis?
90.
That is the answer, 90. So if you listen and if you understand sine of 90, so the force still remains QVB. The only thing is we have to look at the direction. Remember, force has to be perpendicular to both V and B. Velocity is like this. Magnetic field is inside, and if you rotate your fingers, it will be perpendicular to this velocity in this direction. Perpendicular to this velocity in this direction, your force will be going like this. This angle would be 90 degrees. Do we understand this?
Yes, sir.
I'm just not getting voice from your end. Do we understand this, everyone?
Yes, sir.
Boys, girls, do we understand this?
Yes, sure.
Okay?
Akka, sir.
Okay, then you can give me the answer for this one. The velocity is like this. Give it fast. Let us say this angle is 30 degrees, velocity is like this, and magnetic field is coming outside. You have a minus q charge. What is the magnitude and direction? You have to draw it to understand it. Drawing is understanding, seeing is believing. So you have to draw the force so that we understand in which direction the force is going. I will give you 2 minutes. Please give me the answer. If you are not able to get the answer, tell me, sir, we are not getting it. Please solve it. Don't just keep quiet. So this is 2 minutes. Your 2 minutes are starting now. F is equal to QVB. That is correct. What is the direction? In which direction is this force going?
Perpendicular to V, sir.
In which direction? There are
Right side.
right side perpendicular to V. Okay, let us see it. F is QVB. Again, this V is in the XY plane and this magnetic field is now along K axis coming out. So the angle is still 90. The force is QVB. Now I have to look for the direction of magnetic field. So V is going like this. B is coming out. So I have to move my hands like this. It is coming out. And if I go like this, the force will go in this direction. But remember, this is a negative charge. Force cannot go in this direction. So the direction in which force will go will be opposite to it. This angle would be 90 degrees and this would be the direction of force. Do we understand this? Do we understand this?
Sir.
Okay. One more question. The particle is here moving with a velocity v. Charge is plus q. Magnetic field is going in this direction. This angle is 30 degrees now. Now you have to tell me. What is the magnitude and what is the direction of force? Take 2 minutes. Give me the answer.
Inside, sir.
So how are we going to find out the force? F is equal to Q VB. Here the angle between V and B is simply 30. Sine of 30 is half. So QVB by 2. Now you have to look for the direction. Right hand. V is like this. B is here in the XY plane along the x-axis. If you turn your fingers, it goes inside. So the direction is inwards. That is the value of force and that is the direction. Do we understand this? All these questions we have done with using the scalar form of the equation. If you are having any doubts, you can always convert them into vectors and solve the question with the vector equation. But when the force gets in that direction, the vector calculation will have x and y axis, I and j components, and it might look a bit different, and that is why I have not used a vector equation here. Unless and until force and magnetic field are given in vectors, we prefer not to use the vector equation. We prefer to use the scalar equation and turn our fingers and get the answer. Are we all confident with the direction of force in all these cases? Yes or no?
Yes, sir.
All these are questions. They are not examples. All these are questions. They can very well come as question in your exam, and I hope we are confident of finding out the magnitude as well as the direction of magnetic force. That takes us to the next heading of this chapter.
Sir,
Yes,
can you stop the screen sharing and can you explain the direction? How should we take? We are confusing in direction.
V cross B. V cross B. Your first vector should go in the direction of V. This should go in the direction of B, and this will give. Same as DL cross R. Magnetic field. This was going in the direction of DL. This was going in the direction of R. This was going in the direction of magnetic field. V, B, cross. Nothing has changed. The first vector is V. Second vector is V. First vector is V. Second vector is B. And the third vector is force. V, B, force. Nothing else. Nothing has changed. Cross product never changes. Always the same. You understand this? Cross product never changes. The only problem here is if it's a negative charge, you cannot find it from the right hand rule. So you reverse the direction and nothing else. Exactly the same as what we had done in the previous case. DL cross R or V cross B is the same thing. First vector is V vector, second vector is B vector, and the third vector gives us the direction of force. Do we understand this? Or still having some doubt?
Yes, sir.
Understand this?
Yes, sir.
Pakka?
Yes, sir.
Still not sure. You can write it like this. Your first vector is V vector. Your thumb should go in the direction of V vector. Your second vector is B vector. Your palm should go in the direction of B vector. When you curl your fingers, your force will come in the direction of your fingers. It's the same as what we had done. Nothing has changed. Nothing can change because it's the same cross product. Same cross product. I have not changed anything. In the first project, we had done DL cross R. Here we are doing V cross B. Nothing else. Nothing else apart from that. Nothing has changed. I can assure you that. Shall we move ahead? Everyone has understood this?
Yes, sir.
Sure?
Sure, sir.
Okay. Let us move ahead and write the next heading. And the next heading is the heading that we are concerned about. Now we have seen how much will be the force experienced by this charged particle. Now what we are going to see is motion of this charged particle in a magnetic field. So that is the heading that we are going to write. Motion of a charged particle in a magnetic field. So write the heading, motion of the charged particle in a magnetic field. Motion of a charged particle in a magnetic field B. Motion of a charged particle in a magnetic field. Now, this motion depends on a variety of things. So you can do case number A. If the velocity of the charged particle is 0, then I have a charge which is at rest, and I put it in a region of magnetic field. What will happen to that charged particle? What will happen to that charged particle? In which direction will it experience force? And what type of motion it will have? Yes. No one knows this? I'll give you 2 minutes. Think about it. Tell me the answer. Yes, if the velocity is 0, then what will happen?
Force is 0, sir.
Force is 0, sir. Yes, if velocity is 0, then the force is 0, and the particle is at rest. It will remain at rest. Nothing happens. So there is no point of studying this motion. It remains at rest. Now, apart from this particle being at rest, you must remember that the force acting on this particle F is given by this formula QVB sine theta. Now, what type of motion this particle has or will have, apart from velocity, it will also depend on very important factor. What is the important factor on which the motion depends on for this charged particle? It will depend on the value of which one? Which quantity is the most important quantity? If charge is 0, obviously the magnetic force is 0. If there is no charge, there is no force. If there is no magnetic field, obviously there is no magnetic force. On what most important factor this value of or this force of this charged particle depend on? Yes. No one understands this? Okay, it depends on the value of theta. If theta is 0 or 180 degrees, what will happen then? If theta is 0 or 180 degrees, what happens then?
F is equals to 0, sir.
F is equal to 0. That means the particle will continue its motion. For example, if your velocity is like this, and your magnetic field is also in the same direction, or it is in the opposite direction, whatever direction, the force acting on this particle would be 0. This implies force acting on this particle would be 0, and it will continue motion with uniform velocity. Motion will continue with uniform velocity. nothing will change. Motion will continue with the same velocity, nothing will change. Do we understand this? Yes or no? I'll give you 2 minutes to note this down. Let me know once you are done. So if theta is 0 or theta is 180, nothing happens. The particle just keeps on moving with the same velocity, nothing will happen. Then comes the next interesting case. What is the next interesting case? Case number 3. If theta is 90 degrees, if theta is 90 degrees, and that is the case where 90, 95 or 98% of the questions will come from, if theta is 90 degrees, then what happens? Then
F
what
is
happens?
maximum.
F
QEB.
is maximum. So the first point that you must remember is F is maximum, and the maximum value of F is
QEB.
QVB. Now this F maximum will be same in magnitude, but first listen to me, then I'll give you time to write. But changing in direction, it will constantly be changing in direction. Remember this F max will be perpendicular to the velocity of the particle, as well as it will be perpendicular to the magnetic field. That implies that speed of the particle will remain constant. Do we remain this? Do we understand this? Speed will remain constant. Do we understand this?
Yes, sir.
Speed will remain constant, but something will change. What will change? What will change? Speed remains constant, but what will change?
Direction.
Direction of what?
Velocity.
But the direction of velocity or the motion will change. Speed will remain constant. The motion or the direction of motion or the direction of velocity will keep on changing. This particle will follow UCM. Do we remember what is this UCM? Anyone remembers what is this UCM?
Uniform circular motion.
Uniform circular motion. The particle will move in a uniform circular motion with constant speed. Now remember this F max, which is nothing but equal to QVB, will give this particle the centripetal force. This F max will give the particle the centripetal force. This F max will give the particle a centripetal force, which is nothing but equal to mv square by r. And this F max will always be directed towards the center. Since it is giving you the centripetal force, it is always directed towards the center. Do we understand this? This F max or QVB will give you the centripetal force, and it will be always directed towards the center. I'll give you 2 minutes to note this down. Please let me know once you are done. Then we move ahead, sir, and this is how the diagram looks like, sir. Suppose this particle has a velocity v like this initially. As you can see, magnetic field. As you can see, magnetic field is going inside. Do you see this? Yes or no? Cross, cross, cross means magnetic field is going inside. Do we see this? Yes or no?
Yes, sir.
Pakka, everyone sees this? Everyone sees this? Yes or no? Now,
Yes, sir.
if I find out the direction of magnetic force will be QVB because the angle is 90, so the magnetic force will be QVB. If you find out the direction at point A, let me call this point as A, let me call this point as B, this is C and this is D. V is here, B is inside. You can see the direction of magnetic force will be upwards. Yes or no?
Yes, sir.
So here the magnetic force will be upwards, here the magnetic force will be towards left, here the magnetic force is downwards, and here the magnetic force will be towards rightwards. In all the cases, you can see that this magnetic force is pointing towards which point? It is pointing towards the center O. Yes or no? No or yes? Do we understand this?
Yes, sir.
Then we can write simply this magnetic force, which is QVB, is giving it the centripetal force, which is mv square by r. From here, you can find out the radius of the circle, and the radius of the circle will be given by mv by qb. A very important result that you must remember and understand, that whenever the particle is moving such that its velocity v is perpendicular to magnetic field, it is always going to move in a circular path whose radius is given by this formula. Do we understand this? Yes or no? No or yes? The radius r will be given by this formula. We understand this? Yes or no? No or yes?
Yes, sir.
Pakka, sir?
Paka, sir.
Okay. So this is the radius of the circular part. Now you can write it in various ways. So please pay attention while I'm writing. After that, I will give you enough time to note this down. This can be written as momentum peak, magnitude divided by QB. Yes or no?
Yes, sir.
Momentum P can be written as 2 times Km ka root, where K is the kinetic energy. Yes or no?
Yes, sir.
Yes, sir.
Everyone understands this. Now this particle which is moving will be accelerated by some potential. It will be accelerated by some potential. It will be accelerated by some potential, by potential V. Q into V will be the energy. So you can write this formula in this fashion also. The more number of ways in which you can remember this formula, the better it is going to be for you, because remember, JEE is not a test only of your, it's only a test of your speed. The more number of ways in which you can remember this formula, the better you are going to be. Everyone remembers the different variation of this formula? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes now. Take a deep breath. Get this formula into your head. Do not be in a haste. Write them on your own. Understand them. This entire topic just depends on this formula. Take a deep breath, understand them, and write them. So that is the formula for radius of this circular path. Now, whenever we are talking about this radius, now we can see some important things about this radius. The radius of this, okay, I will give that as an important point right now. Let me move on and tell you, apart from the radius, which is the most important thing in this circular motion, we also must understand what is the angular velocity omega and time period. Yes or no? The angular velocity omega is v by r. If you divide v by r, what will you get? You will get qb by m. This is the angular velocity, and as you can see, this angular velocity does not depend on your actual velocity, and that is a very important result. Do we understand this?
Sir.
This omega, which is angular velocity, or you can call it angular frequency, that is what you call it in SHM, angular velocity or angular frequency. Omega is v by r. From there, you can also find out, bacha, the time period. Time period is 2 pi by omega. This time period is also known as time period of cyclotron. This omega is also known as angular frequency of cyclotron. If I inverse the time period, I will get the frequency of the cyclotron. So what is the formula for time period? Time period. It will be 2 pi m by qb. This time period also is independent, my dear friends. This time period is independent of your velocity v. Do we see this? Yes or no? No, yes. You can also write the formula for frequency f. Frequency f is 1 by t. That becomes qb by 2 pi m. This frequency is known as the frequency of the cyclotron. Your cyclotron works on this principle only. So once you have the formula of radius, the rest of the formulae are very simple and very easy to remember. Do we understand this? Yes or no? I'll give you 2 minutes to note this down. So now we can move ahead and note down some important points. These are nothing but the same thing that we have already seen written in terms of points, because I've seen a lot of questions come on this important points. So the first point is, again, I will write all the formula for radius together. All the formula for radius together. I hope you are now acquainted with these formulae. Radius is equal to mv by qb, p by qb, root over 2m by 2mk by qb, and 1 by p 2mv by q, where v is the applied voltage through which it is accelerated. Yes or no? No, yes. Please note it. Please listen to me. Then I will give you time to note it down. Do we understand this? Yes or no?
Yes, sir.
As you can see, this radius r is directly proportional to v, or directly proportional to p, or directly proportional to root over k. That means if you increase the speed or the kinetic energy or the momentum, obviously the mass of the particle cannot change. If you increase the speed or the kinetic energy or the momentum, the radius will increase. Yes or no? No, yes. Yes or no? No, yes.
Yes, sir.
Now, sometimes they ask you the thing of curvature, who has a more curvature. Remember, if radius is less, curvature is more. A thing which is very sharply curved has very small radius of curvature. Do we understand this? Yes or no? No, yes.
Yes, sir.
We understand this, everyone? Do we understand this, everyone?
Yes, sir. Yes, sir.
Now
So
you talk about the time period, or you talk about the frequency, or you talk about the angular frequency. Time period or frequency or angular frequency is independent of the speed and the radius. It only depends on your specific charge ratio, q by m. And I have seen a lot of questions on this Q by M ka ratio. So the time period of frequency is independent of the speed of the particle. As you can see, it is independent of the radius of the orbit. It only depends on B and Q by M. Do we understand this? Yes or no? No or yes?
Sir.
I'll give you 2 minutes now to note them down. Note them down aram se. You should not make a mistake in this part. Most of the questions are going to come from this part, which I have seen come in a lot of exams, in your exam, in many different ways. They always give you a question where they give you two particles and they ask you what is the ratio of radius of the two particles. In most of the cases, those particles are, the first particle is a proton and the other particle is an alpha particle. Does anyone know what is an alpha particle? Does anyone know what is an alpha particle? Does anyone know what is an alpha particle? No one knows what is an alpha particle. Alpha particle is a helium ka nucleus. Helium ka nucleus. So the outer shell electrons have been removed and it is the helium ka nucleus. It has the charge which is equal to 2 times the charge of one proton, and it has the mass which can be taken same as 4 times the mass of the proton. If I take the mass of the proton as m, the mass of the helium nucleus will become 4 times Fm. If I take the charge of the proton as P, the charge of a helium nucleus will become 2 times P. Do we understand this? Then they give you different cases. If they enter with the same velocity, what will be the ratio of their radius? It will be proportional to m by q. Do we understand this?
Sir.
So you will get the ratio of radii. If you reverse it, you will get the ratio of curvature. The second thing, they will give you P same. The third thing, they will give you same kinetic energy. Fourth case, they might give you same potential difference. So just write these. These are nothing but they are directly proportional to m by q or q by m or root over m by q or root over q by m. Just write this. These are like questions which I am giving you in a tabular form. Do we understand this? So do it fatafat. I'll give you 2 minutes to do it. Anyone understand what is here?
Yes,
Yes
sir.
or no? 2 minutes. Do it fast. Now, remember whatever we are doing, I'm just taking inspiration from what type of questions are coming in your exam. The other category of question which come is they have a they give you a particle and then this particle is put between two plates and then they ask you what is the condition when will it hit the plate, when will it not hit the plate. So let me just put that condition here between two plates. When will the particle hit the plate, when will the particle not hit the plate. So first listen to me, then I'll give you time, then you write. So what I have done here is I have released the particle. You can see this particle here of mass m and charge q, and I've released it in a magnetic field. Magnetic field exists between these two plates. Do you see these plates, the pink plates? Yes or no? These are the two plates where I have released this particle, and in between these two plates there is a magnetic field which is going inside. Do we see this? Yes or no?
Sir.
You can call the value of magnetic field as B. One more thing is also given is the distance between the two plates is given as D. Do we understand this? Now they ask you when is the plate going to hit the particle, when is the particle not going to hit the plate. So now looking at the diagram, can you tell me when will the particle hit the plate? When will the particle hit the plate? When will the particle hit the plate?
D is less than R.
D is less than R. That is absolutely correct. Remember, my dear friends, this R is your mv by qb. So the condition to hit the plate, condition to strike the plate is very simple. If you just see it once, so that when the question comes, you are not stumped by the question. To strike the plate, it is necessary that the distance d should be less than r, the radius of the circular path. Yes or no? No, yes. Do we understand this? Huh?
Yes, sir.
Or it has gone above and it's saying bye bye. So if you understand this, to not strike the plate, the condition would be d should be greater than r. Yes or no?
Sir.
Between these two conditions comes the third condition, to just touch the plate. To just touch the plate, my dear friends. To just touch the plate. So what will be the condition to just touch the plate? Yes, my dear friends. We understand all this? To just touch the plate, D will be equal to R. Do we understand this? Yes or no? No or yes? Are we
Yes,
there
sir.
in the same dimension
Yes, sir.
or lost? We are there, no? Huh?
Yes, sir.
2 minutes you have to show your talents. So just to start off the things, I will give you the simplest possible question. It only requires you to calculate things, and I would assume that you can calculate them faster and get me the answer faster. So this is the first question. I'll give you 2 minutes to give me the answer for this one. Option C, sir, is the right answer, sir. You just have to remember the formula R is equal to mv by qb, sir. You can also write it like this. Specific charge. Charge is to mass ratio. So you can write it as V divided by Q by M into B. That is all you had to do. So speed is given as 6 into 10 raised to the power. Don't worry about 10 raised to the power. They will all get sorted out. All the options are in the same power, so you don't have to worry about power. Are you understanding me? Remember, you have to get to the answer in the quickest way. Don't worry about powers. Do not even write powers. You see all the answer in the same unit. So do not worry about the power. So I'm not getting worried about the power. 1.7 into 10 raised to the power 11. Don't worry about the power because it is not going to make any difference. Multiplied by where is the multiplication? Multiplied by 1.5 into 10 raised to the power minus 2. Do not worry about the power. Forget about this. So now 6 divided by 1.5, it is 4. 4 divided by 1.7, you can easily get the answer. Yes or no? The answer would be 2.35. This is how you get to the answer faster and quicker. We understand this? Yes? Or just gone above what I'm saying bye bye, bye bye, bye bye.
Understood, sir.
Huh?
Understood, sir.
Understood, sir.
Well done, sir. Then comes the next question, sir. Get to the answer faster. The same question may appear in your exam, sir. This is the question, sir. No information is given, sir, but the question is asked, sir. Best of luck, sir. Option B, sir, is correct, sir. That is why I gave you that curvature thing, because I know what type of questions are coming. R is mv by qb. Now we are talking about electron and proton. They have same kinetic energy, so we both have same kinetic energy. So I've written the wrong formula. So I should not use this formula. See, in excitement, I said something else. Same kinetic energy. So which formula should I write? I should write this one, root over 2 m K by QB. Yes or no? We understand this, or this is about it saying bye bye? Huh? Are we there in the same dimension?
Understood, sir.
Okay, thank God. I thought you have sneaked into some other dimension, hidden one. Electron and proton both have the same charge. Magnetic field is same. Kinetic energy is same. 2 is same. So radius is directly proportional. So radius of electron divided by radius of proton will be root over mass of electron divided by mass of proton. And you must understand that the mass of electron is very less compared to the mass of the proton. So radius of the proton will be more. Radius of the proton is more. That means its trajectory is less curved. Do we understand this? Yes, no, yes.
Yes, sir.
Thank you, sir. Good day, sir. Not the biscuit, sir, but the day, sir. I love good day biscuit, sir. The next question is here, and I expect a quick fire answer. And the answer is option B. I've already given you this as that table, so it is directly proportional to M by Q, and we know M by Q ka ratio. Yes or no? No, yes.
Yes, sir.
The next question, sir. Give me the answer fast, sir. Uh-oh. This is the question, sir. Give me the answer fast, sir. I'll wait for 2 minutes, sir. Option A is correct, my dear friends. R. They have the energy. You're talking about energy. R is equal to that revolutionary formula 2mk by qb. Now you must understand what all things are same here and what all things are different. 2 is same. The magnetic field is same. Only these two things are same. So I can say the kinetic energy or the energy. Oops, wrong color. I hate wrong colors. Kinetic energy or K or energy is proportional to what? The radius is same. Sorry, the radius is same. The radius is same. So kinetic energy will. Oops, wrong color. I hate wrong colors. So this kinetic energy will be proportional to Q square by M. Kinetic energy or energy will be proportional to Q square by M. Do we understand this? Yes or no? No, yes.
Yes, sir.
So kinetic energy of alpha particle divided by kinetic energy of proton will be Q alpha by Q proton square multiplied by mass of proton by mass of alpha particle. One will be 4, one will be 1 by 4, and the answer is 1. So the both energies must be same. Do we understand this? Yes or no? No or yes?
Oh,
These are the questions that have come many times, and almost all the times they give this proton and alpha particle. These are their favorite questions for JEE. Next one comes. Give me the answer fast so that I can move ahead in life. You have 2 minutes to give me the answer for this one. A proton and an alpha particle enters a uniform magnetic field perpendicular with the same speed. Proton takes 25 microsecond to take 5 revolutions. Okay, the time has come now. What? Then the periodic time for alpha. Remember, read the question. Periodic time for alpha particle would be how much? Your time begins now. So remember, always take a deep breath. Open your eyes and look at the question. 25 microseconds for 5 revolutions. So the time period of this one is 5 microseconds, my dear friend. 5 microseconds. Then we move ahead and write the formula for time period 2 pi m by qb. I have to find the time period of the alpha particle. T alpha divided by T proton will be M alpha divided by M proton multiplied by Q proton divided by Q of alpha. So if you do this, you will get 2. So the time periods are in the ratio 2:1. The time period of the proton is 5. So the time period of alpha particle has to be 10. Do we understand this? Yes or no? Huh? Understand this?
Yes, sir.
Or it has gone above our head saying bye bye. Shall I move on to the next question? Yes or no? No.
Yes, sir.
This is the next question. Read the question. Don't get confused. The same question may appear in your exam. You take a deep breath and then read the question. I'll give you 2 minutes. So which one?
Yes, sir.
Yes, sir.
Now, you can see that these electron or proton or whatever it has initial velocity like this. Yes or no? So if I find the direction of force V cross B, the direction of force is upwards if it is a positive charge. Yes or no? If it was a negative charge, the direction of force would have been downwards. Do we understand this? Yes or no? Yes or no?
Yes, sir.
That means both these particles are moving in the same direction, therefore they have to be protons. Now look at the radius. This radius is more. Radius of B is more than radius of A. Yes or no?
Yes, sir.
Yes, sir.
So now you have the correct answer. Radius is directly proportional to V. Everything else is same. Both A and B will represent proton, but velocity of B will be more than the velocity of A. Do we understand this? Yes or no? No or yes?
Yes, sir.
Pakka, sir? Or this has gone above our head saying bye-bye? Bye-bye?
Understood.
Next question, bacha. Let's see who gives me the answer for this one. Two very long straight particle. Two very long straight, not particle. Two very long straight wires carry steady currents I and minus I. So if plus I is here, minus I will be like this. The distance between the wires is d. At a certain instant of time, a point charge q is equidistant from both the wires in the plane of the wires. Its instantaneous velocity v is perpendicular to the plane. What is the magnitude of force due to the magnetic field acting on the charge at this instant? I saw once a YouTube video where they said wherever there is 0, mark 0, because 0 is the answer. Let's see which logic you apply. And in this case, the concept is correct. Wherever there is 0, you mark 0. 0 is the answer. Why 0 is the answer, my dear friends? Why 0 is the answer? Because of the logic of that fellow? No, that is not the logic. 0 is the answer. We have just now completed magnetic field, but I understand that you would not remember it. If the current is in the same direction, the magnetic field is 0. But if the current is in the opposite direction, the magnetic field will not be 0. Therefore, 0 is not the correct answer. The magnetic field will get added up. Do we understand this? Magnetic field is not 0. Magnetic field get added up. Yes or no?
Yes, sir.
But but the magnetic field is in the same direction as velocity. Do you understand this? That is why you read the question carefully. If you read the question carefully, you will understand that the question is made in such a way that even though magnetic field is not 0, magnetic field is getting added up, the velocity and magnetic field are in the same direction, and therefore, my dear friends, the answer still remains 0. So wherever there is 0, you always mark 0. Do you understand this? Yes or no?
Yes.
Do we understand this? If this question would have been different, if this question would have been like this, one wire is like this, one wire. If the question would have been like this, one wire like this, the other wire like this, and the velocity is given in the same direction, v like this, then the answer would be what you are saying, my dear friends. Do we understand this? So you must read the question carefully and then answer. Do we understand this? Yes or no? No, yes.
Yes, sir.
Here comes a question from the year that I gave my IIT first time. Let's see if you can do justice to this question. A metallic block carrying current I is subjected to a magnetic field as shown in the figure. The moving charges experience a force F given by what? Which results in the lowering of potential of the surface. This is actually known as the Hall effect. Assume the speed of the carriers be v. Take a deep breath. Remember, this is a question of IIT, so it has to be a simple question. Give you 2 minutes to give me the answer for this one.